Welcome back, everybody. Welcome to Math 1314, More in Math. Today we're going to talk about Chapter 3, Section 5, which is solving equations and inequalities with absolute values. Okay. First, remember what absolute values are. So if I had absolute value of -3, the answer is +3. If I have absolute value of 3, the answer is still 3. So all it does is take whatever, that's what I said, value. It's an absolute value. It has to be a number, one number in there. Whatever that is, I just drop whatever sign it is, it's always going to come out positive. Whatever happens inside. If the negative is outside, order of operations, I got to do this first, which gives me 3, and the negative stays on front. So if the negative's outside, it stays negative. You cannot distribute, so the answer would still be -3, because that becomes 3. Now, those are absolute values. Now, what if we dealt with variables? Let's say, well, if we had absolute value of x equals 3, what can x equal? Well, we just saw up here. That if e equals 3, inside there could be positive or negative. So x can either be +3 or -3, which leads us to our rule. Absolute value of x equals some number a. When I drop the absolute values, I put a plus or minus in front of the answer. Because what that means, it's a or -a. So, for example, let's look at an example. 2x minus 3 plus 2 equals 8. So, again, as always, we have to isolate the absolute value sign. So anything plus or minus we have to get rid of, or multiply divided also. So subtract 2 in this case. So those cancel. So I have absolute value of 2x minus 3 equals 6. So now when I drop the absolute values, since it's by itself, I put a plus or minus in front of the answer. This means one of two things. 2x minus 3 can equal +6, or 2x minus 3 can equal -6, or both. Solve for x, so add 3 to both sides of both equations. So 3's cancel. 3 plus 6 is 9. -3 plus 6 is -3. Divide by 2. So x is equal to 9/2. And x is equal to -3/2. You know, always check your answers. 2, remember, this is the equation. So 2 times x, x is 9/2 minus 3. Does that equal 6? So cancel those. 9 minus 3 is 6. Absolute value of 6 is 6. That one works. 2 times -3/2 minus 3. The 2's cancel, so we have negative 3 minus 3. Negative 3 is negative 6. Now I take the absolute value of it. So absolute value of negative 6 is 6, so they both work. So I have both solutions. I have two solutions in this case. All right, so in other words, isolate your absolute value first, and then solve for x. Inequalities. Inequalities with absolute values. We have two possibilities here. X can be less than a, or absolute value of x can be greater than a. Now, it also works, I mean, if it's equal to also. So I'm going to focus on this one. Let's look at what this really means. Here's 0. Here's some number a. Whatever x is, it's less than a. In other words, it's going from there towards 0. But remember, whenever I drop the absolute value of plus or minus, what about the negative a? Again, because it's going towards 0. So all my x's are between a, negative a, and positive a. Because, yeah, it's got to be between negative a to 0, and then from a to 0 to a. So if it's less than, when I drop the absolute value sign, my x is going to be bigger than negative a, but less than a, because it has to be less than a. So here's some number a here. So x, absolute value of x is greater than a. So here's a, x is greater than, it's going towards infinity. So it's away from 0. Likewise, from negative a, has to go away from 0. So it's going to negative infinity. So in this case, x is less than negative a. Since it's going in different directions, x is greater than a. Notice, for the positive side, it remains the same. If it's x less than a, it's less than a on the positive side. X greater than a, it's just it changes on the negative. Why? Because remember, when I change the signs, I change the directions. So if x is less than a positive a, that means it's going to be greater than negative a. If x is greater than positive a, that means it's going to be less than negative a. All right, let's look at some examples here. Absolute value of, let's see, 2. 3x plus 6. Yes, 3x plus 6 plus 1. Let's give you the full treatment here. Is less than 11. Yeah. First step, isolate the absolute values. So get rid of the plus or minuses first. So plus 1 minus 1 cancel. 3x plus 6. 11 minus 1 is 10. Now there's a coefficients multiplied, so I divide both sides by 2. So its absolute value of 3x plus 6 is less than 5. Remember, if x is less than a, then it's between negative a. So when I drop the absolute value sign, looking at this, less than, so I'm going to have this, whatever a is, whatever the number is here, I put on both sides. So I'm going to have negative 5 and 5. The directions are the same. So whatever's inside here goes in there. Now we solve for x. Since we subtract from 6 in the middle, we have to subtract from 6 from the other sides. Negative 5 minus 6 is negative 11. 3x less than 5 minus 6, 6 is bigger, negative 1. So negative 11 over 3 is less than x is less than negative 1 over 3. Those are your answers. Okay, the rest of that stuff is the same, but I'm going to look in the middle now. For this same equation is here. Let's look at absolute value of 3x, no, of negative 3x plus 6 is less than 5. Or it could also be written like that. They both mean the same thing. Since it's less than, remember, absolute less than a becomes negative a. So it's negative 5 less than positive 5. This is my a. I'm putting this example up because I want negative in front of the x. So first off, we get rid of the 6. It's negative 11. 6 is cancelled. And negative 1. Since there's a negative in front of the x, everything, all the signs change, all the inequalities change. So negative 11 becomes a positive 11. Less than becomes greater than. Negative 3x becomes positive 3x. Less than becomes greater than. Negative becomes positive. So I always want an increasing order like this. It's got a point towards the 1. It's got a point towards the 3. And now we can solve it. Divide by 3. So it's 1/3 less than x is less than 11/3. So be careful about the negative signs. Let's do one more with greater than. Five minus 2x absolute value is greater than 1. So there's no coefficient or anything around it. So remember, if x is greater than a, this is a, then it's going to be x is less than negative a, or x is greater than a. So here's a. So this is your x. 5 minus 2x is less than or equal to negative a. This is x and this is a. Or 5 minus 2x is greater than equal to 1. So when I change the sign, I change this value of x. Subtract by 5. So I have negative 2x is less than equal to negative 6. They're both negative, so I add them. Or negative 2x is greater than negative 4. 5 is bigger, so it's negative 5 minus 1 is 4. It's negative, so I change all the signs and the directions of the inequality. So positive 2x, that changes direction, positive 6. Positive 2x, change the sign to positive 4. Divided by 2. X is greater than equals 6 divided by 2 is 3. Or x is less than equal to 2. Let's see what that graph looks like. Here's 3. It's greater than or equal to, so it goes this way. The other one is 2. It's less than or equal to. So those are your answers. Goes from negative infinity to 2, 3 to positive infinity. So, okay, so whenever you get these answers, always check your see what it looks like, because it is possible to sometimes say x is greater than or equal to 2, or x is less than equal to 5. Let's look at the first one. X is greater than or equal to 2. So here's 2. And here's 5. So this one's greater than or equal to 2. So here's 2. Going to infinity. Next one, x is less than or equal to 5. Going to negative infinity. So when you put them both together, if you look at it, it's all the shaded region is there. So it's from negative infinity to positive infinity. So be very careful about that. So when you do these kind of OR questions, put them in two separate graphs. All right, good luck and do the homework.